round of applause for Amos King.
Thank you, Brett. So if anybody was here last time, they probably know that I like to walk a lot, but I broke my ankle in December and I'm going through PT right now, and I get the PT, and he says, hey, I'm going to need you to start doing some squats. What kind of squats are you used to? And I said, diddly. So it's probably going to get worse from here. If this talk doesn't go over well, you can blame me. You can blame Bruce and Randall. Randall for going before me and giving such an amazing talk, and Bruce for putting me right after Randall. So blame them, not me. All right, so importance of shepherding your code. Magic transitions. Keithley showed me those. There's nothing about fly fishing on there. I have 5 children, and I just found out a couple weeks ago that I'm getting ready to be a grandfather. Somebody told me yesterday they thought I was 25, so that was awesome. Founded Binary Noggin, host of Elixir Outlaws. If you've ever listened to that, I started that with Keithley, who is probably hiding somewhere. I don't know where he went. Oh, you're behind the pole. How am I supposed to see you? I'm also recently a board member of the EEF. I really wanted to find a way to give back to the community, so if you are part of the foundation and you voted for me, thank you so much. And if you're not part of the foundation, come talk to me. Well, let's talk about it. And then if you want to send me an email, my email address is on the bottom. Or sign me up for spam. I really like spam. Especially if it's fried. Okay, shepherding code. I am going to try to walk around a little bit because I like to. I wanted to be responsible and burn up a lot of CO2 producing materials, so I generated these images with AI. So I am not responsible for how dark it is that this guy has no face. Shepherding is kind of, when we think about shepherds, a lot of us go back like a few thousand years. We don't think of modern day shepherds. And how many people have a picture of a shepherd like sleeping, taking a break, laying on a rock while the sheep are just crawling all over the hill and not seeing what's going on? It's not really that realistic. I mean, shepherds had to track thousands of sheep. We'll call them processes, right? And they needed to be able to know the sheep so well that they could recognize one that was sick or sniff out sickness before it got through an entire flock. It was a highly stressful, busy job. So this is my awake, I said on watch shepherd. He's not very on watch. He doesn't realize that there's like an alpaca that showed up in here. I have no idea. He's got a gun sticking out of his back. Looks like he just brought the 10 Commandments down. I don't know what is going on. But this is really what we need to be and what shepherds needed to be. They needed to be on watch, awake, on guard, guns hanging off their back. I don't know. That's the one of the most important things in shepherding. Like we talked about finding those sheep that are sick. And how do we do that? Typically we debug. Or this also, anything that is useful in debugging is also useful for exploring a project. I'm just going to make stuff up. Ooh, I can still see. This is really messing with me. If anybody wants the slides, they're right there. You can just watch. It's really useful in exploring new projects, too, that you've never been on. So if anybody takes you in the first day and then tells you that you need to go debug something and you've never worked in it, sweet. You'll be fine. You got the tools to do it. So it takes time and money, though. It's really expensive. But nice thing about Elixir Erlang is we have some really powerful built-in tools. But let's talk about the time spent, right? 30 to 50% of the time spent in debugging, and this comes from a study from I don't remember. It was in my notes. We'll see later. But there's an article in ACM that talks about this and references the study that talks about this blue screen, 30 to 50% of the time of an engineer is spent debugging. So I hope you really like debugging, because you're going to spend about half your time debugging in your career. But what does that come down to economically? 50 to 75% of a software project's budget over the life of the software is spent on analyzing and debugging. So how can we be better citizens and better about building on these projects is by figuring out how we can lower that. We want it as close to that 50% or lower than we can. And I think that the power of the tools that we have in Elixir can allow us to do that. I think that's one of the game changers for us. So I'm so turned around here. So let's figure out how we can find these in our own sheep and find out the problem. So what tools, does anybody remember this? Yeah? Yeah? If you do, you're old. Congratulations. This came out in 1993. I wrote and sold my first software on the TI-85. I made a little game. I called it Barrel Racer. My friends called it Text Racer, which I will demo here in a second, because I wanted to see if I could rewrite this using LiveView, because, right, that's what you should use things that are delayed over the internet for, is reaction-based games. Yeah. Beautiful. So this is what it looks like. The original TI-85 was 8 rows by 21 columns, so I matched it perfectly. And let's go see. Whoop. We're gonna hide this part. Ignore that. That's the next part of the talk. So we got this little game here. We can start driving, and we can speed up. And well, there's the bug. You see the bug there. So this was actually a real bug that I had in the original software that I was selling to people at school for $5. In 93, I could like buy a house. Well, maybe 2009, I could buy a house. All right, so that was the product. You saw the bug. So we're going to figure out how do we find that bug. Again, generated by AI. I asked for a sheep bone x-ray. It's the weirdest direction for ribs I've ever seen. So what are some of the built-in tools? So this is when I start asking about this to people. These are the tools that they give me. IO inspect. Great. Kernel debug. Okay, a nicer IO inspect. I'm just going to tell you what they are. IEX pry is kind of a step debugger. It kind of works. And then IEX helpers is the thing that people leave out, and I think that's the best thing in that list. And so we'll go over a little of those today. That's the end of that list. So the problem with like inspect, kernel debug, pry, most of these tools is you have to pull the code down locally. You have to change the code. You have to recompile. It takes a lot of time. Yeah, thanks. Just turn that for them. Perfect. This half gets it. The other half, yeah, enjoy yourselves. So you have to recompile. You have to pull everything down. You're putting in these statements everywhere. You don't know where they're going to go. Every time you need to change something, you got to move them around. You have to find them and pull them out. And then what happens if it only happens in production? Now you're going to go put these in production? No, you're not. Like, this is a terrible experience. And pry is even worse. So we have lots of sheep out there, right? And I have one sheep that wants to call another sheep, and it expects a response, and that other sheep I've frozen in time with pry. And now I get a timeout. Or I have users that hate me because I put an infinite timeout and I lock everybody out. Not okay. So what's better? There's a whole suite of tools called Recon. This is by Fred Hebert, and we're going to go through some of these tools today. Well, really one, just Recon Trace. Telemetry is really powerful in production and can give you a lot of information, and can help you debug, but you need to know up front where you need to put those things. And when you're debugging, like, you're moving into the unknown. You don't have time to put them in up front. You may not want to redeploy because you need to fix it now. We're trying to save that that percentage of our time and percentage of our budget, right? So, recon trace really has one function that we care about. This recon trace calls, and we're going to get into what this does, but it takes in a trace spec, which is a specification for tracing something, the max number of times you want to trace it, so that this pulls itself out automatically out of production, so you're not tracing forever and slowing down your system, and then a set of options. All right, so the AI for this was Rambo, the sheep herder. That was awesome. When that popped up, I was like, this is perfect. I don't need to generate any more. I can save one more family of cars. All right, so let's go look into our debugging. The other thing that I have here for this debugging is... Oh, I don't know. This won't have moving background, so... And we're mostly done with the slides. We'll go back to them once. All right. Okay, so I have this running in the background. There's a little bit of setup here. We don't need to go over that. I don't know, can everybody see this, or should I make it bigger? Bigger. Tell me when. Good? All right. So live books are also pretty fantastic for debugging if you can connect them to your remote server, and you can. Click this over here. I'm going to disconnect so I can show you this. Configure, click attach node. It tells you that you need a cookie. You can look up how to configure that. And you can connect to it. And now we should, all right, be up and running. The reason that live books are amazing for this is you can have your debugging code right here, and then whenever you're done, you can share it with the other developers so that you don't actually have to fix the bug. Yay! At least that's my goal. All right, I'm going to shrink this side over here a little bit. All right, so when I start debugging, this is kind of how I go, and this is also how I explore a new system. So I debugged this. I injected this bug on purpose into the code. So how I debugged this was I went away for hours, came back, did a little bit of debugging, and then went away for hours to forget what I was doing, and came back and did a little more. And this is the actual session of how I debugged this. So the very first thing is we have application get key, and this is the application name, and I want to get the list of modules within that application that I know I'm debugging. So first day, and we run this, and I get this nice, beautiful list of every module within the application. And then I say, what parts of this look interesting? Game, maybe. Looks interesting. Row, I don't know what a row is, but we have rows on our screen, so maybe that. Probably don't care about most of these other things, but there's a game live. That might be interesting. So I then use the built-in helpers, the IEX helpers, and start looking at what are the modules, what do they mean? So I look at help first. Help is this separator thing is just something I always throw in. It just prints a bunch of equal signs so I can have a bunch of statements in one place. Uh-oh. That's not supposed to happen. It is a debugging opportunity. Did I just did this in the back this morning. Do what? You have to require it, or is it import? I swear I did this morning. Hey, thank you. Thank you, whoever said that. So we have a game. We have a text racer game. I don't know why. I don't need to look back there. I'm just going to keep looking right here. So the game says the data for the game handles ticks and user input. So ticks in a game are when the clock goes by. That's what makes movement. So every tick you process, and then a new state of the game comes through. A row is a representation of a section of the roadway. Interesting. Game live, that's the live view. So what does game data look like? So we have the type helpers. So let's see if there's any types in there. And there are. Let's see what those are. So we've got position. Types can be really helpful. Please put types at the top of your file, even as documentation. So we have a position. It's a non-negative integer. We have a game. It's got a bunch of stuff in it. Debug, height, obstacles, position. So position and track here seem interesting to me, and I want to know more about those. So you notice that when we do type on the file, it gives you all of the types. But if you individually look at types, this is really important, and it actually gives you the type documentation for that type. So we have position is the column that the car is located in as a non-negative integer, so we're probably counting. And then a track is a list of rows. All right, perfect. And it's a track without a car, so there's no car on the road, on the track. So we know that row doesn't seem to take care of it. All right, so I actually left this in here, this args arity. So I use this all the time. This was my proof that I use it. So down here, down at the bottom, you see args arity, and I thought it was arity. So I did my helper and was like, wait, what are the options here? Oh, it's called args arity there. So types really help you get past any problems. So please, I'm going to ask you again, please document the types that are going around. All right, so now we've got like a picture of what might be going on in the system, but let's really see what goes on the system. So this is a trace, and I'm stealing this and walking over here. This is the match spec that or the T-spec that I talked about. So this is the module that you want to trace, the function, and so we're going to say any function, and then the arguments to that function. We're going to say any set of arguments. And I wanted to look at game live, and row. They seemed like they might have something to do with this. And then I want to look at just the arity of the function. So I usually start out with arity and I want to look at 100 traces, and then I want it to disconnect. I start with arity because I'm just looking for what's the path through the code. If you put args in there, then it shows you all the arguments, and when you have big structs and different data being passed in, it gets really hard to read. So I start out with just arity. So let's see what happens. We run it. Oh, there it goes. So it prints out a whole bunch of information here. I'm not even playing the game, and we see that there's ticks going on and handle info, tick options. I'm curious like what that handle info is doing because I'm not even playing. So let's grab the args from that. So this time I'm switching to use args. And here we go. It's running. We got some arguments. Handle info takes in broadcast. It's a clock tick. So that's a tick event, just moving the clock forward. And to me, that it's probably not interesting because what we saw is whenever we're moving, we have things collapsing. So I probably don't care about the tick event. So we'll ignore that from here on out. But as an aside, this is production safe, right? Safe-ish. You can really mess things up if you put giant numbers here so that you're like, I want to trace 5 million traces, and it'll be bad. So I'm trying to trace everything here in the whole system, and it's got to put hooks everywhere. It's going to slow your system down. So this is Fred's beautiful thing. You get an error, and it tells you it's a dangerous combination. You can't use this. It won't let you put hooks in everything in your system and slow everything down. And in fact, once you set a trace with calls, if you try to set another one, it throws the old one out. So that's why you can pass in multiple traces. So you can't end up in a state where you're tracing everything in your system, slowing everything down. So I don't think it's a live view problem because it seemed to be a game state problem. So let's look at game and row. And again, look, it's going so fast that I can't even get over here to cause the bug to happen. And it says recon trace rate limited trip. So that means that we made it through, I did 10, I think. Yeah, 10. So 10 of them went, and then it takes itself out of the system. So you also aren't slowing it down. So I want to know more about these functions and what do their arguments look like, because these seem to be where to me, where we want to be. Let's try to start driving and then hit this and see if there's anything else that happens. We've got tick and speed and score. Yeah, let's see what we can, if we can get some more by looking at the arguments. Oh. And got to reset this. So let's see what we can get here. There we go. We've got some arguments up here. What do these look like? I've got a score. It's got rows, lots of rows. That's a track. What else is an argument in here? We've got a ton going on. I want to go fast. I'm just gonna skip ahead. Shh, don't tell anybody. All right, so we did see the problem where if I'm sitting still, it's still running, and that's obnoxious. So we can put matchers in here. And so it gets a little complicated, and there are easier ways to do this. I'll show you in a second. But we're looking at that speed, that struct up there has speed in it. And so we want to know when the speed is greater than 0 or smiley face speed 0. And this last block says, I just want to make this run only in this case. If it returns okay, then run it. And we're going to drop that on the game so that we only get traces when the game is actually running. So let's see if that works. All right, that 22 right here, which we couldn't see earlier because everything was flying past, that's the number of functions that are going to match this tracing. So if you ever get a 0 there, you typoed something. All right, so now let's see if we start moving. Oh, there we go. Now it only happens when we move. That's super useful. But what the bug is that it's getting too small. This looks like something to do with row to me. Maybe not the whole game state, but just the row. So let's look at row then. Oh, what does row have? It has a column, an obstacle position, and a width. So column and width seem kind of interesting and related to me. So a column is a column on the row, so like vertically, and it's a non-negative integer, so it's probably a position somewhere. How? And we have a width, which is the full width of the row, including the barrels. So it includes the side. So like this is a width of 3. That's a width of 1. That seems like a problem. And then so now I want to dig into row. So now we have this other helper, exports, that gives you a list of all the different functions that you can have. And what functions look interesting to you all? Let me hide this. Anybody? Update? Anything else? Collides at? Set side? All right, so I said set side and update. Collides at's another good one. The reason I didn't pick collides at is because it had a question mark on it, so it looked to me that's a Boolean, and we have collision detection seems to be working. So let's just look at set side and update. All right, what do these get? Okay, here's an update. It gets a row, and then this says shrink. Here's a row. Oh, here's set side. It gets a little character in a row. I don't know what that does. Here's another update. It gets a right in a row. So I'm not getting enough from the inputs, but maybe if we add the outputs. So to add outputs, we just add return trace as part of our trace here, and we can now get both the inputs and the outputs. And let's see what we get with that. Start this running. All right, so here's an update call. And it's got a row, and it says left. It's got left is 3 and 15. And then this little arrow is the output of that call. So we have the call, and then right afterwards the output of that call. And look, it moved the left side -1 and the right side -1, so it moves the whole thing left 1. Okay, so now that's starting to look like we only really probably care about update. because it's what's setting up our movement. But it's getting really hard to capture when I need to get to the air, right? And this gets complicated and hard to get, and really some bugs are unpredictable. So we're going to create this little capture function. This is the easier way to do that match spec that I had earlier. And so look, we want to look at when we have left and right and a minimum width, and when right minus left is less than the minimum width. So the right side is always bigger, it looks like. And so this would be a width of 20. And we want to say, when is it? So it says minimum width is 5, but that's obviously, some of these are shorter than 5, right, that we saw. So let's only get it whenever we have problems. Anybody want to come play this? There we go. We've got some down here that say we're under the minimum width. Let's just grab one of them. So 12 and 16, that's 4. That's under the minimum width. And this thing is updating the row. But look, here's a shrink, 11, 15. And it got... Should have kicked it out sooner? Oh, yeah. Well, I think minimum width, the way that we trace this is a math problem. So right minus left, yeah, we should have kicked out. So that's good. You notice this looks like where the bug is. So let's see get our help text up here. What does this take? It takes in enlarge left, right, shrink. It takes in the game and returns a new game with updated barrel positions. So now let's look at shrink only to get rid of even more of the problems that we see. So we have shrink only and only when it's really tiny. So let's look at this very end one. Shrink, they're 2 apart, minimum width of 5. So these tools, the reason I wanted to show this is because these are really useful in production. They're really useful in saving you time and effort, and they're really not that hard to use. I think I just used the word really about 10 times. These tools are readily available within our ecosystem, and I don't see a lot of them outside of this ecosystem. So use this and learn about it and sell it to your boss, sell it to everybody who wants to not use Elixir or Erlang, and tell them about these. And there's a great book that details a lot of the other things in Recon that you can use called Erlang in Anger by Fred Hebert. It's free. Go download it. You will learn way more than I could show you. Okay, so I wanted to go a little bit. The match specs are not as complicated as they look. Don't full screen? Is it? Okay, good. Thank you. So the middle part is actually the most complicated. The rest, this is pattern matching. We're used to that, and we're assigning a variable name to it. Variable names suck. They're terrible, and you need to keep track of them. But we can, this right here is, does anybody know what an S expression is? Yeah, Keithley does, of course, Keithley. Anybody ever written Lisp? Okay, so that's all this is. This is a function, and then the arguments to that function. And this one happens to be another function, subtraction, and the arguments to that function. So not near as complicated as it seemed. But I don't like writing them. So there's another tool, ex2ms, which you can use this, and the output of that is that S expression. So you can just play with that in your IEX and see what you can do. And this will also tell you when you do stuff that S expressions won't, or well, match specs won't work. So this will generate all that for you. Some options, I'll leave that for later. So here's all the different tools of Recon. So I showed Recon Trace, but there's tools for looking at memory issues. The high-level functionality here has a lot of stuff about looking at system health. Go dig into these tools, please, please, please. And I'll upload all of these files to, I'm going to go back here. If you want to actually go look and fix this bug, there's a GitHub URL here. I can make this bigger. So you can pull it down, and I will add the slides and the live book and everything later today, so it'll all be in that same repo under that same with bug branch. And if you really want to have fun, turn on the delay so that this looks like it's actually on a server somewhere else to about 100 milliseconds and try to play this game. So yeah, go out there and be a shepherd. Do good work. Take care of your systems. Know how they work inside and out. These tools can help you. And if you don't get anything else out of this today, how many people are flying out of here? Okay, so I'm going to give you one last thing. When you get on the plane and you're sitting next to a person that you don't know, lean over to them and say, so how long are you going to spend in Montreal? And then just go with it. Thank you.